since this is the way it works, so there's all kind of interesting rules that come out of it. For example, we learned object-oriented programming in our freshman year that once a function is declared virtual, it's virtual in the base, derived, even if you don't write the word virtual. For example, if we write here class derived against the base, and we write public, and we write, for example, void, foo, and against an int. Now notice, obviously, it has a different implementation. This has implementation B, and this thing has implementation A. I don't really care, right? But I didn't write the word virtual, it still remains virtual. Why is that true? The reason is very simple. Because if you go back to our picture from before, we look at our tables, right? Once the function actually was allowed or put into the vTable of the base, it has to be in the vTable of the derived, because the vTable of the derived is just a copy of the vTable of the base plus whatever the derived added. And therefore, it's already there. Once it's already there, then there's no reason in the world why I have to write it. Now, it's good practice to write the word virtual just so everybody knows and reads your code, doesn't have to guess what's going on, but it's actually virtual anyway. We know we have what's called pure virtual functions. What are pure virtual functions? Those are functions that have this no implementation sign. Now, that doesn't mean there's no implementation. You could have an implementation for a virtual function, a pure virtual function. But the idea here behind it is if you go back to our table and we look at the function, the idea is that there is no function pointer here. There's no pointer to where it's pointing at. But rather, what we have inside of here is just a null. Now, what that means is that if anybody tries to dereference and run the function like we try to do right here, then that wouldn't work. And therefore, the compiler does not allow you, it doesn't allow you to actually implement or actually create an object of a class that has a pure virtual function. And as I said, the reason for that is because this code can't work. It has no way of working. You can only create an object of type derived, and then you must overload that function, that no function pointer, you must overload it, and therefore for this code to work. So all you're doing when you're writing equals 0, all you're actually doing is you're telling it, put in the vTable the number 0. Now, give it the value 0, and therefore there is no function pointer, at least the function pointer is null, and therefore you cannot go and you cannot actually instantiate any object coming out of that function. So here we have another rule that comes out of the way that the thing's actually been implemented. The last thing I want to talk about as far as these implementations are concerned is now more of a theoretical issue. Suppose we have a class that has no virtual functions. None. What does that really mean? So if we think about it for a second, what that actually means is that there is no vTable. And if there is no vTable, then in a sense it's not meant to be inherited because there is no polymorphism going around. So you might inherit it just for implementation issues, but it might be actually wiser to just, instead of inheriting it, to just put it as one of your data members. You're getting the same functionality. You're not getting anything from the inheritance that you're actually doing. So when a programmer goes and creates a class that has no virtual functions, what he's essentially telling you is, do not inherit this. There is no vTable. There's nothing you can work with. You have to. It's just a incorporation way. It's not an is a relationship. It's a has a relationship. But if there's even one virtual function in the class, what the program is actually telling you is that this class is meant to be inherited. Otherwise, why is it creating a vTable behind the scenes? Now, suppose, for example, that you do not have even one function that you could think of that should be inherited. But you do want to allow the programmer to inherit for all kinds of mechanical reasons or other ideas. So the way it's actually done is by having a virtual destructor. Now, you might say that you must have a virtual destructor anyway. But if you think about it closely and carefully, you would see that any time that you have a a hierarchy, the destructor must be virtual. And therefore, by definition, it doesn't do with the vTable. By definition, you would say that you have to have virtual anyway. So why write the word virtual? So that would actually is the reason for that is for the programmer is telling you, listen, I couldn't find a function for you to actually go and override in your derived version, but I expect you, yes, to inherit from me, and therefore I'm creating this virtual function. So this virtual destructor. So I'm saying there's all kind of now theoretical things that surround all this entire concept. But overall, what we're seeing here is all kind of rules and standard behavior and programming practices and all kinds of language criteria that come out from the way things are actually implemented behind the scenes. And that's actually the point I wanted to bring out.